Okay, so we're going to look at an example here where we're going to find intervals where a graph is concave up and where it's concave down. So the function we're going to look at is going to be, it's going to have a couple different parts where it's concave up and down. So it's um, a graph that goes up and down quite a bit. So we're going to look at the graph of 2x to the 6th minus 9x to the 5th plus 10x to the 4th. Okay, so let's just first kind of look at this graph intuitively. If I go here, so I'm going to be looking at this graph. So this graph kind of would hold water here, so that's going to be concave up. This section is going to be concave down, and it's going to be concave up again. All right, so we'll come back to this once we get an answer and be able to analyze it. So in order to find where it's concave, we need the second derivative. So in order to do that, I'm going to take f of x. The first derivative is going to be 12x to the 5th minus 45x to the 4th plus 40x to the 3rd. Okay, so for the next example, that was supposed to be first derivative. Okay, for the next example, I'm going to find the second derivative. So that's going to give me 60x to the 4th minus 180x to the 3rd plus 120x to the 2nd. Okay, second derivative test is a lot like the first derivative test and how to find critical points. In this case, it's going to help us. Later on, we'll talk about inflection points, but it's also going to help us define where things are concave up and concave down. All right, so we definitely need the second derivative. So I'm going to do a second derivative test. In order to do a second derivative test, however, I need to know where these values equal 0. So I need to know when 0 is equal to 60. And I'm going to pull out a 60x squared over this entire function. And then that's going to leave me with x to the second minus 3x plus 2. Okay, and luckily this is it's factorable. So I've got 60x to the second times x minus 2 times x minus 1. All right, so we seem to have 3 points back on this graph where things were changing. So we had a value in here, we had a value over here, where it was changing. So it's coming in here and here. So those are some critical points. So we're going to look at x equals 0, x equals 2, and x equals 1. All right, so just as we look at this intuitively, x equals 0 doesn't seem like that's where it's going to change concavity. X equals 1 certainly does. Okay, and x equals 2 is also a possibility of where it's changing. All right, so let's look at what's happening when we do a second derivative test. So I'm going to plug in 0, this is 1. These aren't critical points because second derivative, they're actually called, could be called inflection points, but we don't know if they're inflection points yet. Okay, so I'm going to look at the second derivative. Okay, the second derivative is negative 1 of negative 1. I want to look at the second derivative of 0.5. I want to look at the second derivative of 1.5. And then I want to look at the second derivative of 2.5. Okay, so when I look at these, okay, I'm kind of going through and I'm looking at the regions of what happens. Okay, when I plug in negative 1 into the second derivative, which is this function right here, I get a positive value. And when I plug in 0.5, I get a positive. When I plug in 1.5, I get a negative, and I get a positive. Okay, so when we look at this, okay, the first derivative, we're looking for where the first derivative is greater than where it's positive and where it's negative. So it's positive here, here, and here, and then it's going to be negative right here. Okay, so okay, so we're going to then look at where the graph is concave up and where it's concave down. So I'm going to go to the next step here, and I'm going to say the graph then is going to be concave up from negative infinity all the way up to 1, negative infinity up to 1, and then it's going to be concave up from 2 to infinity. So I'm looking for the values where it's positive, and then it's going to be concave down from 1 to 2. Okay, so let's go back, and now that we have this graph, let's see if that makes sense, or we have this answer. Let's see if that makes sense with the graph that we had. So those are my answers I have here, and this is my graph. Okay, so it's saying it's concave up from negative infinity all the way to 1, and then it's concave up from 2 to infinity, and it's saying it's concave down from that was 1 to 2. That's supposed to be 1 to 2. That's supposed to be a comma here. From 1 to 2. So that makes sense. So you can use your intuition on a lot of this stuff to figure out concavity, is looking at the graphs and working back and forth.